Was also on the reference table. Now, so far, all 5 gas laws that you worked on the quiz today did not have what quantity in it. Anybody know? Didn't have moles or grams. Okay? So today we're going to focus on including quantities that have moles and grams. All right. So today we're going to do the ideal gas law. Now, the ideal gas law is different from the ones we've done in 2 ways. All of the formulas that you used on the quiz today, with the exception of Dalton, okay? Dalton was just pressures. So if you think about Charles, Bowles, Gay-Lussac, and the combined, how many temperatures did you have in those laws? How many volumes did you have? How many pressures did you have? How many does this one have? Well, that's 1. Okay, 1 pressure, 1 volume, and 1 temperature. So you're not going to have, if the volume is this and then the volume is that, you're not going to have 2 temperatures, you're not going to have 2 pressures. All right? The other significant difference about this law is the N. All right, so when you look at this particular formula, P stands for pressure, just like always. V is volume, just like always. And T is temperature. But N and R are our focus for today. N is moles. Some people always ask, why is it not M? Well, M stands for what? Stands for mass. And we'll do a formula, maybe late today, but probably tomorrow, that has M in it, and it's going to be mass. Now, R is called the ideal gas constant. And there's multiple ways that I can teach this because there's 3 different gas constants we can use, okay? And I can teach it with changing gas constants based on pressure units. Or I can elect to teach it with 1 gas constant and we can change the units. All right? Over the years, I have found that we tend to do better if we just pick one and stick to it. So that's the way I'm going to do it. All right, so we're going to choose to use the ideal gas constant of 0.0821 liters times atmospheres over moles times Kelvin. Now, I know that looks bizarre, but that is the ideal gas constant in its units. Normally, the units is Kelvin, or the unit is atmosphere. The ideal gas constant has 4 units, all combined. When we did density, it had grams over milliliters. It had 2. This one has 4. Now, the thing about the ideal gas constant is it dictates the units you have to use in the problem. Okay? So every time you use this ideal gas constant, what unit does your volume have to be in? Your volume has to be in liters. If you don't change your volume to liters and you use this formula, you get the wrong answer. Did everybody hear me say that? Okay. Did I just say that the questions you did on that quiz over there now have to be in liters? No. If you use a formula that has R in it, it has to be in what? Liters. if it doesn't have R, does it have to be in liters? No. Did those formulas on the quiz I just took up have an R in it? They don't have to be in liters. But any formula that has R has to be in liters. Pressure has to be in what? Pressure has to be in atmospheres. Now, N has to be in moles. Temperature always has to be in what unit? Kelvins. Temperature, it does not matter what formula you use, has to be in kelvins. Did everybody hear me say that? Yeah. Temperature must be in what unit? Kelvins. Doesn't matter the formula. Temperature is in kelvins. Volume is in liters. Pressure is in atmospheres. If you use a formula with what letter in it? R. Is V1, P1 equals V2, P2 going to require liters and atmospheres? Why not? Doesn't have an R. Everybody hear me say that? Y'all are going to ask me that 400 times between now and the test. Okay.
Wait, say it one more time.
Do I have to put my volume in liters? Why not? There's no R in the formula. Do I have to put my temperature in kelvins?
Yes.
Why? Temperature is always in kelvins. Okay? All right. We're going to work this one. We're going to do about 3 of them just to get some variety. We're going to talk about how they're different from what's on the quiz. And then we're going to practice. All right. Tell me what's different about this question. Okay, that's moles. That's one thing that should make it really easy for you on the test, and it should jump out at you. Okay? And most people recognize that and have no trouble with this one because it does jump out. What else will jump out at you and scream, okay, I'm not a V1, T1, or a P1 over T2 kind of thing? Okay. That doesn't usually scream a whole lot about us. Huh? Okay, how many STPs do you have? You only have one temperature and pressure, okay? That's just a T and a P, and you only have how many of them? One, okay? So you've got moles and one temperature and one pressure, okay? And because you only have one of each, that's going to rule out most of what you did on the quiz. You can't use a V1 and, or sorry, not a V, a P1 and a T1 because, excuse me, if you want to use this, all right, if you were thinking I have a pressure and a temperature, all right, genius. Could you plug into that? No, because you only have one temperature and one pressure. So most of you are going to be able to rule things like that out pretty quickly, okay? So when you go to plug into PV, equals nRT, which is what most of you are going to think. All right, let's go with that. Okay, PV, nR, and T. Get rid of that for right now so I have some space. What's my pressure? 1 atmosphere. All right. Give me something else we know.
270 Kelvin.
Okay. Give me something else we know. Which letter does it go with? N. 0.0680 moles. All right. We got 2 missing, so we got to have one of them. So it goes where? Okay. So R is 0.0821. It's a constant. R never changes. Okay. So we're solving for what letter? Check to make sure everything's in the right unit. Is it in the right unit? Yep.
Wait, do you have to do anything like the liters, atmospheres, moles, Kelvin?
That's what we're talking about. Are they all in the right unit? Or are you asking me about do I do anything with the unit on R?
Yeah.
Nope. That unit for R dictates the units that everything else is in. So that's why I said, are we in the right unit for everything? So is pressure in the unit it needs to be in? Yep, it's in ATMs. This one's in kelvins. That one's in moles. So we're good to go. All we have to do now is plug in to our formula. And because we know R is what it is, what unit is our volume going to turn out to be in? It's going to come out in liters. Okay? So pressure is 1. Volume we don't know. N is 0.0680. R is 0.0821. And temperature is 273. So volume equals is what? 1.5. I didn't hear the last thing. 2. We'll just go 1.52. All right. And because we said what we did about R, the unit was what, Sailor? Liters. You write liters on the end. And you're finished. Huh? It is really easy. The ideal gas law, I think, is probably the easiest gas law we do.
Okay, what's the catch?
Nothing other than it's rare that all the units are going to be what you want. Now, the state might give you all the units that are the same like this, but I won't. No.
Because that'd be too
Because we're an honors class.
Wait.
What's the challenge if I give you all the units that are correct?
That's the point. Don't just memorize.
And this is also the law that will push us into the stoichiometry part, too.
We already did stoichiometry.
It's coming back with the gas laws.
Wait, stoichiometry is what?
Balanced equations. So we're going to put in volume ratios and then use the ideal gas law with it, with balanced equations. All right. So this is an easy one too. We're going to do one like this and then one where we do maths. And then I'm going to let you practice. It's up to you. I'm going to do 2 that are, I'm going to do 3 that are different. This is the second one that's different.
This is the second one?
This is the second one that's different.
So we should write this down.
I would recommend that you write this one and the next one. And then I'm going to give you some stuff to practice. All right, so if we look at this one, what can you tell me?
That
We're gonna switch grams to moles.
Okay, grams has got to go to moles.
we're gonna switch.
All right, so,
C is gonna go to K.
all right, so tell me where I'm going to put the letters or the numbers beside the letters. So where's the grams going to go? Beside the N, all right. And where's the 25 going to go? Okay. And where's the 15 point? Nope, I already got that one. There's 150 going to go. Okay. And I need one more number. What are we putting in beside P or R?
0.081.
Okay. So we're looking for P. All right. And you guys have already said we got to change all three numbers I gave you this time. So temperature's got to be changed to what? All right, Kelvin. So 25 plus 273 is 298. I don't even know why I added that. I'll do that one in my head now. All right. So this is why I said you might want to just know the 1,000. Some of you can do this one in your head now. Some of you can't, but this will save you a lot of time and not having to draw King Henry because milliliters is just 1,000. All right, so 150 divided by 1,000 is 0.15 liters. All right, we got to change grams to moles. Remember how to do it?
Yes. You're going to draw the shot.
Grams to moles. What goes beside moles?
1,
And
28.
Oh,
No,
no.
yes, no, I don't
is
know.
28.
that's what I'm asking. Is it or isn't it?
I don't know.
All right, so diamonds out there trying to remember, is nitrogen diatomic?
I know it's diatomic, I just didn't know if it was 14 or not.
It is 14. It is diatomic. 14 times 2 is 28. She does have the right number. Okay, so 14 times 2 is 28. So 0.54. Now, I will tell you, our answers are going to differ when we get an answer, depending on how you round. This is where the biggest difference comes from. Most of us don't struggle here. We'll round to 0.15. We'll write 298. Some of you will round that to 0.5. Some of you will write 0.54. And some of you will write 0.542. Your difference in rounding there will change your final answer. So when I call out answers to questions, that's where the difference is going to come in. So don't get bogged down in, well, my answer is it right? If you're close to what I called out, the answer is what? Yes. Okay? But that's why we will not have the exact same answer.
That's more by whole numbers.
Whole numbers in some cases. Okay? So let's get to the final answer and I'll give you an example of it. Okay? So when we plug into PV equals nRT, all right, we're looking for P. Volume is 0.15. N is 0.542. R is 0.0821. And temperature is 273. So to get P by itself, I've got to do what? Divide by.
298.
Oh, thank you. Let me fix that. 298. Okay, I've got to divide by what? 0.15. So I'm going to divide this side by 0.15, and I'm going to divide this side by 0.15. So pressure equals 0.542 times 0.0821 times 298 divide 0.15. I got 88.4. And the unit will be atmospheres because I found pressure. Now, let's say that I rounded to 0.5.
What if I leave it?
Huh?
What if I just leave it at 80?
It's fine. Now, if I rounded to 0.5, I just rounded up to 82.
Okay.
Now, if I rounded to 0.5,
Oh, that's a lot.
no kidding. That's my point in this. Some of you are going to make me work questions in the homework that you got correct because of the way you round your information. You didn't do the problem wrong. Okay?
Say it's safe if it's more than 10 or more.
Not necessarily. You got to show your answer because, or your work to me, because sometimes if this was, let's say this was a number that was in the hundreds, okay, this answer's in the hundreds. and this was rounded, this might be different by more than 100 or more by 10. It might be different by 20 or 30. You can't just use a 10 as a rule, okay? So
I don't know.
my advice to you is not to round to a single decimal place. If you take it out, let's say 2 or 3 decimal places when you find your moles, you're not going to get differences that are great like that for my answer. That's how you solve that problem. If you don't round to one place behind the decimal and chop it at one place, take it out 2 or 3 places like I did there, and you will not have this issue. Okay? That will solve the problem. But most people won't listen to me and they chop it off at one decimal place. Okay? Now, last problem that we're going to do together. And we're also going to work this one with a different formula. Probably not today, probably tomorrow. With big M. With the molar mass formula. This one is on the board.
Didn't they figure out the molar mass?
Yeah, but we're going to do it with a gas law formula.
What does it say? 30 what?
I think it's 300 milliliters. Yeah, 300 milliliters. All right, so let's look at what you've got. What are we solving for? You're solving for moles, right? Now, and usually that's the mistake people make. They stop at the problem too soon. And that's the only piece I really want to talk about in this question is the common mistake that's made. Because at this point, everybody, well, most people, will have no problem solving. So I just want to cover the common mistake that's made. And is everybody okay with where I put the numbers at this point? Because I just sort of filled it in. So would everybody be okay with where I stuck the numbers? Okay. So could I just make the conversions and everybody be okay? So this one would be 0.3 liters. 356.8 divide. This would be 3.52 atmospheres. This one would be, I think, 300. Would everybody be okay with those conversions? Okay. Now, solving for moles. We would have 3.52, 0.3. We need N. So how do we find N? What do we do? Okay.
Multiply all the numbers.
You know I'm not going to multiply. What am I dividing by?
0.82.
Okay. Now, what do I have? What have I got? Yes. What I have just found is moles. And this is the mistake that's usually made. Is that the answer? No. And that's where people tend to stop. Okay? You have found moles. N stands for moles, not grams. So what do you have to do with what you've got? You've got to convert it. Okay? So you're going to take this and you're going to stick it in a chart. No, you can just wait on me to take 10 points off on the quiz.
So
When is that?
not.
What's today?
What?
What's today?
Wednesday.
Friday.
We're gonna have a quiz on this on Friday.
You'll have a quiz on this and these two formulas tomorrow. We're learning on Friday. All right, so moles gets a 1. And what's the thing we're using in the question? Is it diatomic? Okay, so 35.4 times 2 is 70.8. So times 70.8 is 3.03. Grams. Questions?
So did you say that equals N or not?
No, that equal, well, you could say it's equal to N, but technically it's not N anymore because you changed it to grams.
So if they ask you to solve for, wait, so why don't we change it to grams?
Because the question says what mass,
Oh,
and mass is always grams.
so if they ask for moles, we just use the first answer?
Yep, if they ask for moles, you stop it in. Since they want grams, you have to change it to grams. For the G-chart. You will have a quiz on Friday. Friday will involve this formula plus the 2 we're going to learn at the beginning of class tomorrow. And they work just like this one. They'll be easy.
I hate these worksheets.
Okay. I don't care.
I thought you would be like, I'll do something.
I don't care. It doesn't hurt my feelings. It's not a democracy here. It's a dictatorship. So it's not like her opinion counts.
This mine.
No, it don't matter either. All right. So we're going to do questions 1B and C. We're going to do 2C. Matter of fact, we're going to do all the way through 7C. Yeah.
Wait, so is that 3C, 4C, 5C? Or like,
Yeah. 2C, 3C, 4C, 5C, 6C, 7C. I tried very hard not to say duh at the end of that.
That should be enough for me. Okay, that's enough.
Not done yet.
is this homework too? Or is this just classwork that we need?
It's just
We got like less than 10 minutes.
I'm aware. I can tell time. Now I'm done.
so is that 12C through 15?
12C through 15C. So 12C, 13C, 14C, 15C.
Okay, I'm glad like I know that dash is.
Okay, a wise one over there.
Well,
So 1B.
1B and C
And then like 2C.
through 7C and then 12C through 15C.
Does that include A's and B's?
No, it's only C's.
Oh.
It's 12.
It's 12 and 7.
No problem.
Okay, I'm glad you can count and tell time.
I didn't tell time, I was someone else. So.
Geniuses, all of y'all.
Hey.
If it's like the other night, it doesn't matter. 13 of you are gonna take zeros anyways if I can. Huh?
It was a rough day.
So if I check tomorrow, it won't be as rough a night?
Yeah.
Probably not.
And why on earth is Angel packing up? You're supposed to be working on math. Because if we're not, I'm gonna talk about molar math. Because if y'all are done, I'm going on to molar math. It's right there.
Oh, hold on. Please go back. I don't know what it is.
Get that out of here.
No,
Which one are we choosing?
no.
Homework or molar math?
Question, are you playing with my life?
Then work.
Wait, I don't know what it is.
Wait.
I'll give you a hint. 1B and C is Avogadro's principle from yesterday. So look at the volume. What can you tell me about the volumes? Are they the same or are they different in 1B?
We leave in 5 minutes.
I'm aware of the time. I'm glad that you've excelled in time in elementary school. I'll give you a hint. Time is not on the exam.
I've come a long way with that.
It is only 18.
I really couldn't. Like, I struggled.
I can tell you that half my classes in 4th period still can't read that class.
My mom used to make fun of me. I mean, I don't like reading. I mean, if I really have to, but like, I can read it.
Most people probably prefer not to, but you have the ability.
Yeah.
You're checking us tomorrow?
I would tell you there's a high probability. To quote Caroline, there are 12 questions. Sure.
I don't think I did this right. I'm confused.
What can you tell me about the volumes? In the question and in 1B, are the volumes the same or different?
This is Lulu.
Guys, listen to me in 1B. What can you tell me about the volumes in the question and in 1B? So what do you know about the number of molecules?
Oh, so I did that right. Oh, okay, cool.
Okay, so in 1C, what can you tell me about the volume in the question and in C? So it's doubled, so what do you do to the number of molecules? So you multiply by 2.
Okay, so there's 10 questions.
Now there's 10 questions you have to do. See, I cut your homework down by 2 questions. Stop loading.
So you cut off.
So we
We
don't.
just did 2.
No, you told them. You didn't do it on the board.
There's no work, genius. You just write down the answer.
When you multiply by
We'll
two,
write the
just-
answers on the board. No, everybody's afraid to.
Okay, so.
You take this number, the whole thing, and multiply by 2. Exactly. It will probably change the whole one. It'll probably go up to like 24.
Oh.
It doesn't.
It doesn't change this time.
Okay, so. I don't use
Do we have to show our work?
No, not for 1B and C. There's no work. For B and C, you're only multiplied by 2. The rest of them should have work.
I'm confused.
Explain what?
Wait, so the other two
In 1B, what can you tell us about the volumes? It says 5 liters in the question. It says 5 liters in B. This is Avogadro's principle. If the volumes are the same and the temperature and pressure don't change, what do you know about the number of molecules? It's the same. So they did it backwards in the question. They told you the number of molecules are the same. So what do you know about the volumes? They're the same. Okay, so when you look at this, I told you had, where we at? Right here, we had summer molecules, and we have 5 liters, and 5 liters. So the volumes are the same. So if you have this many molecules, how many molecules you're gonna have, the volumes are the same. So we need that number of molecules. You just write down that many molecules you're gonna have.
I have something to say.
Ah, yes. That's all you gotta do.
For this page, do we use the information?
All right, put your calculators up so we're ready at 9:55.
That's in what?
Yes, we're gonna take moles and molecules.
25.
1 mole, just 6.022, just 6.0 molecules. But it's, no, it's a review question. Keep it up for me.
I just said that I was gonna be.
They're all-
Are they not ready to go? You're converting with molecules, moles, and moles, molecules.
Look at me.
I think it's right here. I didn't think it was.
Let me see. Let me see.
I got it.
I guess that you guys, I guess.
I'm coming up to
Do what? It's a 79 question test. You're coming
Oh,
out.
yeah.
How can you get a question?
Like,
You better work fast.
for like $200.
I was there all the time.
And I spent $40
You better be done by 4 words.
I was never.
Because they didn't have it.
Okay.
I wasn't at the bottom when they put in.
Here,
Right.
sit back
Wait,
here.
so what was the answer?
Sit back there, so it'll be so rough again.
It's an A.
This whole, what all do we do for instructions?
You just have to explain the ones you got wrong.
Do we have to do that at school? Or can we do it here?
No, you gotta do it here with me. I'm not eating lunch outside right now. So I'm cold, so if you got third lunch, you can come to our lunch. Then, yeah, you gotta do it after school.
Wait, yeah.
Oh, yeah. Thank you.
Well, you are staying after, right?
Yeah, yes.